Yeah. But we are on notes on page 18. And like I said, today's not going to be too stressful, but you absolutely need to know how to do today before we do tomorrow, which tomorrow will be taking it up a notch. But today we are going to learn about something called extraneous solutions. And you've heard of them before, but just without giving them this crazy name. Extraneous solutions are what we're going to label them. Extraneous solutions are the definition. So first we're going to write it down, then I will explain it. Extraneous solutions are a solution that must be rejected because it does not satisfy the equation. So let's write that down and then I'll explain what that even means. So an extraneous solution is a solution that must be rejected. A solution that must be rejected because, I'm going to shorten because is just BC, because it does not satisfy the equation. Okay, what that means is when we have a problem, the denominator can never have a 0 in it. Anytime you take something and divide it by 0, you're going to get an error. So write that down. The denominator can never equal 0. That's super important. So if I have a fraction like 1 over x, x can be any number but 0. X cannot equal 0 because if I substitute 0 in for x, I'm going to have 1 over 0. And if I go to graph that, my calculator is going to be like, whoa, no, no, no. You cannot have any zeros in your denominator. You can never divide by 0. It's math illegal. There's not that many rules in math, but that's one of them. Alrighty, so an extraneous solution would be the value that makes it be 0 in the denominator. So for this first example, we're not going to really follow these steps. I'm going to shorten it. I'm going to make it much shorter. But jumping into this first example, the very first step we are going to do is find our extraneous solution. We are going to find what value of A that we don't want. What value of A do we not want to happen? Because if we substitute A into the problem here, we could get 0. So the very first thing we want to do is figure out what can A not be, because if I have A be that certain value, it's going to give me 0 in the denominator. So let me show you what I mean. So you're going to have an example like this. And the question is going to say solve for X, or in this case, solve for A, excuse me, we're working with A. Solve for A, but the very first thing you need to do is check for any extraneous solutions. What I mean is we need to figure out what A cannot be. And in order to do that, we're going to take wherever we see A in the denominator. So I see A in the denominator right here. We're going to take where we say A just in the denominator, so only in the denominator, and set it equal to 0. So I'm going to take 3A minus 1 and set it equal to 0. You have to do this on all the problems. So wherever your variable is in the denominator and in the denominator only, you're going to set it equal to 0. And then we're going to solve for A. So I need to get A by itself. So you always work from the outside in. So I need to work from the furthest away from A. So I'm going to add 1 to both sides. I need to get A by itself. So now I have 3A equals 1. And then to get A by itself now, remember this is 3 times A. In order to undo multiplication, I'm going to do division. So A is equal to 1/3. Just two-step algebra. You guys have been doing this for years. So what I'm going to say, we do not, I'm going to put a line through that equal sign. A can be any value as long as it's not 1/3. Because if A is equal to 1/3, when I substitute in 1/3 into this denominator here, I'm going to get 0. You don't have to do this when you do the problem, but just looking here, I have 3 times A, which if A is 1/3 minus 1, 3 times 1/3 is just 1. 1 minus 1 is 0. So if A is equal to 1/3, then in the denominator, when I substitute that value in, I'm going to get 0, and we don't want that. So the first thing you want to do is check for an extraneous solution. This is a solution that must be rejected, right? So an extraneous solution is a solution that must be rejected. So we're going to solve for A now. We're going to take some steps and figure out what A actually is equal to. And as long as A is not equal to 1/3, we're good. All right. So we didn't exactly solve for A. We solved for what we don't want A to be. We don't want A to equal 1/3, but now we're actually going to figure out what A is. And this is how we're going to figure out what A is. When we have a problem like this, when we have two rational expressions that equal to each other, we have two proportions. And you can solve for two proportions by cross multiplying. This is a concept you definitely know how to do, but maybe it's been a long time. We're going to cross multiply. For cross multiplication, you multiply what's in the same little bubble. So you multiply the diagonals, and I'm going to multiply 4 times 2 times 2a plus 1. When you have two things put together like this, keep them in parentheses. Those need to stay together. Because when you cross multiply, you have 4 times 2a plus 1. Keep those in parentheses because you're going to have to multiply 4 by both of those. And by putting it in parentheses, it'll be easier for you to remember. Keep the equal sign. Keep this equal sign right here. And then you're going to multiply also 3a times 1. Again, put the number out front and keep that 3a minus 1 together. Oops. Let me erase this little squiggly. There we go. Okay. Now I'm just going to start cleaning it up. So I have 4 times 2a and 4 times 1. 4 times 2a is 8a. 4 times 1 is 4. Equals 1 times 3a is just 3a. 1 times negative 1 is just negative 1. It's the same thing. And then I need to get all of my a's on one side and all of my numbers on the other. So you guys definitely know how to do this stuff. I'm going to subtract the 3a from both sides. And so I have 5a plus 4 equals negative 1. And then you need to get all of your numbers on one side. So I'm going to subtract 4 from both sides. So that I have 5a is equal to negative 1 minus 4 is negative 5. In the chat, what is my last step going to be to solve for a? In the chat, please. Please don't unmute yourself. What is my last step going to be to solve for a? Divide by 5. Good. So then a is actually equal to negative 5 divided by 5, which is negative 1. And so a is equal to negative 1. That is a good answer. So we solved for a, and as long as a is equal, so this is a good answer. If a was equal to 1/3, we would have to cross it out and say no. We'd be like, nope, not good. So this is a good answer. My extraneous solution, a could have been anything except 1/3. So a is negative 1, so we're good. You have to check, you can't just skip right to the cross multiplying because you have to check for the extraneous solution first. Alrighty. Any questions? All right, let's do another one. I have this problem here. I want to solve for G, but I first have to figure out what G cannot be, because if G is a certain number, I could have a 0 in my denominator, and that's not good. We will break the math rule. So remember, I first have to check for extraneous solutions. So you have to take anytime you see G in your denominator and set it equal to 0. Look here, though, I see it 2 different times. I have G in the denominator 2 different times. So I'm going to take both of my denominators and set them equal to 0. Take both of your denominators and set them equal to 0. I have 3G minus 6 equals 0. Take that denominator and set it equal to 0. And I have 6G plus 2 that I'm going to set equal to 0. Now, I didn't have to do that before. I didn't set 2 things equal to 0 in my problem before because I only had, I'm going to erase this cross multiply so you can see, I only had A in the denominator in one place. I only had A in the denominator right there. Now I have G in the denominator in 2 different places, so I need to set it equal to 0 2 different times. And I need to solve for G twice. So I have 3G minus 6 equals 0. I'm going to add 6 to both sides. 3G equals 6. To get G by itself, I'm going to divide by 3. G cannot equal. Remember, we're solving for extraneous solutions here. G, we do not want G to equal 6 divided by 3, which is 2. So G cannot equal 2 because if it does, we'll have 0 in the denominator. And we need to also see what else G cannot be. So I have 6G plus 2. I'm going to subtract 2 from both sides. 6G plus 2, or I subtract 2 from both sides. I have 6G equals 0 minus 2, which is negative 2. Divide by 6, divide by 6. If you put that in your calculator, G equals negative 2 divided by 6, you will get negative 1/3 simplified. So put that in your calculator. G cannot equal negative 1/3. Alrighty, so that's not, you're not done with the problem. You need to figure out what G actually does equal, but as we don't want G to equal either one of those 2 things. If G does, then we're not in a good spot. Okay, any questions so far? Alrighty, now in order to actually solve for what G is, we are going to cross multiply. Keep in mind, this is a negative 1 over 6G plus 2. So I'm going to make sure this negative, I'm going to cross this negative out and put it by that negative 1, just so I don't forget. I don't like how the negative's on the side there, so I'm going to cross it out and put it by that negative 1. But now we're going to cross multiply. Okay. And my cross multiplying is not that cute. Remember, when you have 2 things put together, make sure you put them in parentheses so that they stay together. But cross multiply, I'm going to multiply 1 times 6G plus 2. Keep that equal sign in the middle. Equals. Then I'm going to multiply 6G minus 6 times negative 1. So negative 1, 6G minus 6. Remember, this is a negative 1 because there's that negative sign right here. Right here is a negative sign. So I crossed out this negative and I just moved it by that negative 1 because it makes more sense to put it there. And then we cross multiplied. 1 times 6G plus 2 will just give me 6G plus 2 equals negative 1 times 3G is negative 3G. Negative 1 times negative 6 is a positive 6. Questions so far? I need to get all of my G's on one side, all of my numbers on the other, so I'm going to add 3G to both sides. I have 9G plus 2 is equal to 6. I need to get my numbers on the other side, so I'm going to subtract 2 from both sides. 9g is equal to 4. Got to get g by itself. It's okay to get some not nice numbers. Going to divide both sides by g. G is equal to 4 over 9, which I'm going to throw that in my calculator to make sure it doesn't simplify, which it doesn't. And since g is not equal to 2 and it's not equal to negative 1/3, we're good. We're good here. Any questions so far? Alrighty, I have one last example for you that is not in the notes, so you'll need to find room for it, but I promise this question is on your it's on your practice for today, and it's actually on your test with different numbers, of course, because it's a good question. So you want to find room. If you have the packet, you can find room like in this space here, because hopefully you didn't write as big as me. I'm going to find room and cheat like right here. But you want to, I'm adding a problem. You want to write this down. This problem is so important. I would actually star it because you need to know how to do this problem. The problem I'm going to write is 2 over x plus 4 equals x over x squared minus 16. So there's a problem like this on your test. I've already made your test, and there's not a problem like this in the notes. So we are adding a problem like this in the notes. This is the last problem we're doing, and then you'll have time to do 3 problems. You just have 3 problems to practice. Okay? The first thing you need to do is figure out what x cannot be, right? You need to figure out what x cannot be. And so I am going to figure out what x can be. So you're just going to take the 2 times that you see x in your denominator still. So I see x in the denominator right here. And I see x in the denominator right here. Okay, I see it happen both times here. And when that happens, I am going to figure out my extraneous solution. So off to the side here, I need to do some math. I'm going to take x plus 4 and set it equal to 0, right? Where anytime I see x in the denominator, got to set it equal to 0 because I want to figure out what x can't be. And I'm going to take x squared minus 16 and set it equal to 0. Alrighty. The first one's pretty simple. I'm going to subtract 4 from both sides. X is equal to 0 minus 4, which is negative 4. And we don't want x to equal that. As long as x doesn't equal negative 4, we're good. As long as x doesn't equal negative 4. And then over here, listen carefully to this one. I have x squared minus 16 equals 0. So I'm going to get the x squared by itself. So I'm going to add 16 to both sides. I have x squared equals 16. I need to get x squared. I need to get rid of the square. So in order to undo that square, I need to take the square root. I need to take the square root. So if I take the square root, that will get x by itself. The square root of 16 is 4, but also notice it is plus or minus 4. The square root of 16 is positive 4 and negative 4 because 4 times 4 is 16 and negative 4 times negative 4 is 16. That's going to be super important when we get to our answer. So x cannot equal positive 4 or negative 4. We have x cannot equal negative 4 here, and x cannot equal positive 4 or negative 4. Either way, x cannot equal any version of 4. Okay. Now we are going to cross multiply. We still need to figure out what x actually does equal. So we're going to cross multiply. This is where it's going to get a little tricky. So pay attention. Cross multiply. Remember, keep the two things in the denominator together with parentheses. So I have 2x squared minus 16. Keep the equal sign in the middle. Equals. And then x times x plus 4, keep the parentheses together. Now we're going to clean this up. You're like, Ms. Bishop, it's getting towards something I'm not really sure about. Let's clean it up one at a time. Follow with me. 2 times x squared is 2x squared. 2 times x squared is just 2x squared. 2 times negative 16 is negative 32. Again, you can check that in your calculator. Equals x times x is x squared. You know that. X times x is x squared. And x times 4 is 4x. Any questions so far? Now, I can't get all my x's on one side and all my numbers on the other because I have x squareds. I have three things here. I have x squareds, I have x's, and I have numbers. When you have that, you want to get them all on the same side, and it's going to clean up actually pretty nicely. So when you have a problem like this, get everything on the same side. So I'm going to bring everything over to this side. So in order to do that, I'm going to, subtract by x squared. X squared's like term is 2x squared. So if I'm going to subtract by x squared on this side, I can only subtract it on this side by its like term. So I can only subtract x squared by 2x squared because they are like terms. They are both x squareds. All right. When I do that, I have 2x squared minus 1x squared. 2 minus 1 is just x squared. Then I have minus 32 equals 4x. I still need to get this 4x on the other side. So I'm going to subtract by 4x. Listen carefully to this part here. When I subtract by 4x on both sides, I don't have a like term for it to go with. I don't have a like term for it to go with, so it's just going to go on the other side. When you have an equation, it always goes in the form of x squared plus x plus the number. When you have an equation, so I'm going to put this minus 4x over here on this side, on both sides, but when I rewrite it in a nice line, it's going to go in the middle. I'm going to have x squared minus 4x minus 32. Because anytime you have an equation with x squared, x, and a number, it has to go in this order. X squared has to go first, x has to be in the middle, the number with the x in the middle, and the number by itself at the end. It has to go in that order because now this is something I can factor. Now this is something you can factor. You can solve for x. Remember, you know how to solve for x by factoring. The factors of 32 that add to negative 4. You have your factor chart, but I will tell you for the sake of time, my factors of 32 that add to negative 4. I'm going to pick 8 and 4. And I want it to be negative 4. So with 8 and 4, the version of 8 and 4 that will get me negative 4 is going to be a negative 8 and a positive 4. Negative 8 plus 4 will get me negative 4. So negative 8, x minus 8, and a positive 4 will get me, by the way, since there was nothing left on the other side, this equals 0. So now that I factored, now I need to solve for x. You know how to do this from day one. From day one of this semester, I need to solve for x. So I can take x minus 8 and set it equal to 0. And I can take x plus 4 and set it equal to 0 to solve for x, I take my two factors and set them equal to x. I'm going to add 8s to both sides. X is equal to 8. And then I'm going to subtract 4 from both sides. X is equal to -4. X is equal to 8 and x is equal to -4. I'm almost done. I need to make sure that this follows the rules. In the beginning of the problem, you set up the rules. You said x cannot equal, all the way up here. In the beginning of the problem, you said x cannot equal, well, you said, wait, you said x cannot equal -4. But one of my answers was x equals -4. So you need to reject that solution. When you have your test, the only answer here is going to be x equals 8, if this was a question on your test. On your homework, your only answer would have been x equals 8. You need to show me how you got both of them, but you showed me that if you have x equals -4, your problem will not work. So you showed me up here that that was an extraneous solution. So the only answer here is x equals 8. Sometimes you'll get two answers that do work. If I got x equals 8 and x equals 2, then it worked. But this didn't follow my rule. Okay, so this problem, we did take it up a few notches, but follow the steps. Hopefully you took good notes on this problem. If you can do one of these problems, you can follow the steps and do them all.